Hi, in this video we're going to be talking about the hypotenuse leg theorem. Now the hypotenuse leg theorem is a reminder that this doesn't work, but the hypotenuse leg theorem does. It's an edge case where this actually kind of works. We're going to see we've got an angle side-side situation down here. We're going to prove that they're congruent, but this only works if you've got a right triangle. The key thing is right triangles. This won't work in general, but if it happens to be a right triangle, hypotenuse leg says that, hey, yeah, you can get congruent stuff. So if I look at these two triangles, I can tell that I've got a right angle. So ABC has to be congruent to DEF. And I know that those two have to be congruent because they're right angles, and all right angles are congruent. I'm also given a couple things that are congruent as well. So I can say CB and FE are congruent to each other. And that's just given to me in my diagram. And finally, we can say that these two tens have to be congruent to each other. So AC is congruent to FD. That's just given. I just see it in the diagram. And I am able to say that those two triangles have to be congruent to each other. It might be angle side side or side side angle, but we're actually able to prove this one, not by these, but by hypotenuse leg. The two pieces that I was actually given, this side is actually the hypotenuse of a right triangle. And this 6 is the leg of a right triangle. So I've got a hypotenuse and a leg, and a hypotenuse. So we're able to use hypotenuse leg theorem to mark these two triangles as congruent. So I can say triangle ABC is congruent to triangle DEF. So in this example, we're looking at two segments tangent to a circle. So we got NI and RI are tangent, and we know that those have got to be right angles. That's part of the definition of being tangent, is that if you draw an angle with the radius, you're going to make a right angle with the segment. We also know, apparently, that O N and OR are the same. Oh, those are both radii of a circle. So that's kind of like the definition of a radius, saying that those two things have to be congruent. And then OI is congruent to OI. Oh, that's a thing that we know about reflexive property. So let's write in our reasons for these. So this is the reflexive property. The ON and OR, that was the definition of a radius or a circle. Either's fine. Definition of a radius or a circle. And then these purple ones, that is the definition of what tangent means. Okay, so then by that property, we're able to say that those two triangles are congruent, not by angle, side, side. That's not a thing. There is no such thing as that. What we do have is a leg right here and a hypotenuse over here. So we're able to use hypotenuse leg to prove those two triangles as congruent. So we can write a triangle congruence statement using O and I. Has got to be congruent to ORI. And then to prove this statement as congruent, we can now say that NI and RI are congruent to each other thanks to CPCTC. Corresponding parts of congruent triangles are congruent. All right, so we're given a little bit of information. We're trying to prove that these two triangles have to be congruent. So we know AD and BC are congruent to each other. So that's already marked on my diagram. Bop, bop. There we go. We got that. We also know that B and D are right angles. So we can mark that right here. The last thing I think we can mark as congruent is this guy right in the middle. That is a nice reflexive property. So we can say AC is congruent to AC. Now, I want to say that those two triangles are congruent. It might look like we've got angle, side, side, but that's not allowed. We're not allowed to do that. However, this side is the hypotenuse of this right triangle. Same thing with this other right triangle. And this side is the leg of that right triangle. So we can use hypotenuse leg to say that those two triangles are congruent. Just need to fill in my reasons. This was the reflexive property. And then my other two were givens. And that's done. A little bit more practice on that justification. We know JM and WP are congruent. So JM and WP are congruent. That's just given. That was just something that showed up in the definitions of the thing. We've got these parallel lines, and we've also got some perpendicular lines. So we know JMP, so we know JPM, and WMP are right angles, thanks to this little thing. This is just the definition of perpendicular. That's what perpendicular lines do. They make right angles. And then our last one is saying that PM is congruent to MP. So that's this line right here. That's just our good friend reflexive property. Things are congruent to themselves. So this lets us use hypotenuse leg. We know it's hypotenuse leg because this is the leg of this right triangle. It's also the leg of this right triangle. And the hypotenuses are also congruent. This hypotenuse right here for this right triangle, and this hypotenuse right here for this right triangle. So we can use hypotenuse leg. So I'm going to go by 1 and then 2. So JMP is congruent to triangle WPM. All right, so this one's got a bunch of errors in it. So I've made a mess here. But this'll work. This'll work. Really what we want to do is we want to just justify stuff, okay? So A and N, these two are congruent. We know that these two are congruent thanks to these two perpendicular things. This is the definition of perpendicular. Then we've also got the fact that these two angles down here, these little ant angles, those two have to be congruent to each other. Thanks to this definition of bisector. And then finally, we've got YR is congruent to YR. So this side right here is congruent to itself. That's our friend, the reflexive property. So much so, like all the normal stuff. But the reason this example is here is just to remind you, if you've got a right angle, that's not a guarantee that it's hypotenuse leg. If I look at what I've marked in here, I've marked a side, an angle, and an angle. So I can use angle, angle, side to say that these two triangles are congruent. Just because we've got a right angle doesn't mean we're always hypotenuse leg. So be careful about which one you are using. Then we need to write a triangle congruence statement for this thing. I'm going to go NYR. That's got to be congruent to AYR. And that is done. Now in your notes, you're going to see there's another couple examples on this next page with overlapping triangles. We're going to do those together in class, so these are going to be changed to lecture problems, so don't worry about them. What you do want to worry about of this video is this hypotenuse-leg theorem for right triangles. This property does not work, but if you have a right triangle, you can use a version basically of angle side-side in order to prove the two triangles congruent using hypotenuse leg. Thanks for watching. Bye bye.